We're going to continue our discussion on division of polynomials. At the end of the session, should be able to, number 1, prove remainder theorem and factor theorem. Number 2, apply remainder theorem in finding the remainder of the given polynomial divided by a polynomial x minus c. And number 3, apply the concept of remainder theorem and factor theorem in solving for the unknown value. Take note that the focus of our discussion and division of polynomials is remainder theorem and factor theorem. What is remainder theorem? The remainder theorem states that if a polynomial function p of x is divided by a binomial x minus c, then the constant remainder r is equal to p of c. Let's say 5 times 4 is 20, or 20 divided by 4 is 5. Remainder is 0. We can write 20 in another way, that is 20 is equal to 4 times 5 plus 0. 20 is the dividend, 4 is the divisor, 5 is the quotient, and the remainder is 0. We let p of x as our dividend, x minus c as the divisor, q of x as the quotient, and r as the remainder. Take note that our divisor is in the form of x minus c. Using addition property of equality, we can say that x is equal to c. Replacing the value of x to the given expression, it becomes p of c equals c of c times q of c plus r. C minus c is 0. Bring down q of c plus r. 0 times q of c is 0. Bring down r. 0 plus r is r. Therefore, the value of p of c is the same as the remainder when p of x is divided by x minus c. What is the use of remainder theorem? We use remainder theorem in finding the remainder of the given polynomial divided by a binomial x minus c without actually dividing it, or without actually using the long division. For example, for number 1, find the remainder when we divide x to the 4th plus x squared minus 2 by x minus 5. First, we let the given dividend equals to p of x, and the divisor x minus 5 equal to 0. Using addition property of equality, the value of x is equal to 5. Replace the value of x in the given expression. So we have p of 5 equals 5 raised to 4 plus 5 squared minus 2. P of 5 is equal to 625 plus 5 times 5 times 5 times 5, meaning 5 raised to 4, you're going to multiply 5 by itself 4 times. That's why we have 605. And then 5 squared means 5 times 5 equals 25. Bring down negative 2. 625 plus 25 is 650. Bring down negative 2. 650 minus 2 is 648. 648 is the value of the given polynomial using remainder theorem. And at the same time, it is also the remainder. We're going to verify our answer using our knowledge in synthetic division. Okay, first, you're going to arrange the dividend in descending order or descending powers. Shall we say that the given dividend should be arranged in standard form? Notice that the given dividend is arranged in standard form, but there are missing terms. The missing terms are the cubic term and the linear term. So we are going to replace the missing term by 0. 0x cubed and 0x respectively. Our divisor is x minus 5 equated to 0. Then using addition property of equality, again, the value of x is 5. Then bring down all the coefficients of the given expression. The coefficient of x to the 4th is 1. Then the coefficient of x cubed is 0. The coefficient of x squared is 1. The coefficient of 0x is 0. And then the constant term is negative 2. Our multiplier is 5. Then, bring down the first term, 1, on the third row. All the numbers on the third row will be multiplied to our multiplier 5. So 1 times 5 is 5. The first and the second row will be added. 0 plus 5 is 5. 5 times 5 is 25. 1 plus 25 is 26. 26 times 5 is 130. 130 plus 0 is 130. 130 times 5 is 650. Negative 2 plus 650 is 648. The last term is the remainder. So notice that the remainder is the same if we're going to use either the synthetic division or remainder theorem. Another example, if we're going to divide x raised to 100 minus 7 by x minus 1. Again, we let the dividend equals p of x. And the divisor, x minus 1, the constant term is negative 1. Change it to positive 1. So therefore, this will be our value of 4x. Substitution, p of 1 is equal to 1 raised to 100 minus 7. Simplifying, 1 raised to 100 is 1. Bring down negative 7. 1 minus 7 is equal to negative 6. Negative 6 is the remainder. Another example, number 3. Find the remainder when we divide x raised to 51 minus 3x plus 4 by x plus 1. Again, you're going to let the given dividend equals p of x. Then solve for x to our given divisor x plus 1. In order to solve for x in a given divisor, you must equate it to 0. So x plus 1 equal to 0. Using addition property of equality, x becomes negative 1. Then, replace all x by negative 1. So we have p of negative 1 equals the quantity of negative 1 raised to 51 minus 3 times the quantity of negative 1, bring down positive 4. Simplifying, we have p of negative 1 equals negative 1. You might notice that the given expression, negative 1 raised to 51, becomes negative 1. Why? Whenever we raise a negative base to an odd exponent, we're going to get a negative value. To our given expression, the base is negative, and the exponent is odd number. Again, if the base is negative, the resulting value is a negative, because the exponent 51 is odd number. And multiplying 1 by itself 51 times, the answer is the number itself 1. That's why the answer is negative 1. Again, if we're going to raise a negative base to an odd exponent, the resulting value is a negative integer. The base is negative 1, so the answer is negative because the exponent is odd number. Then negative 3 times negative 1 is positive 3, bring down positive 4. P of negative 1 equals negative 1. 3 plus 4 is positive 7. Simplifying, negative 1 and 7. Notice that the numbers to be added are opposite in sign. one is negative, then the other is positive. In order to add the two unlike signs, just get the difference of the two absolute value, that is positive 6, and get the sign of the higher number. The larger number is positive 7. So we're going to affix the sign of the higher number to our difference. That's why the answer is positive 6. Positive 6 is the value of the polynomial using remainder theorem, and at the same time, this is also the remainder. Sample number 4. Find the remainder when we divide x minus x cubed plus 9 by x plus 2. As you notice, the given dividend is not arranged in standard form. It doesn't matter because we use remainder theorem. Again, we let the dividend equals p of x, then solve for x to the given divisor. In order to do that, another way of finding the value of x is just simply look at the constant term. The constant term is positive 2. Just change it to negative. Then replace all x by negative 2. P of negative 2 is equal to the quantity of negative 2 minus the quantity of negative 2 raised to 3 plus 9. Then simplifying, we have P of negative 2 equals negative 2. Just bring down negative 2. And then take note that our operation here is subtraction. Then the expression is negative 2 cubed. Take note, as what I've said earlier, when we raise a negative base to an odd exponent, the resulting number is a negative. So, negative 2 raised to positive 3 is negative 8. Then bring down positive 9. The operation between negative 2 and negative 8 is subtraction. Take note that in subtracting two sign numbers, you just simply change the sign of the subtrahend. The subtrahend is negative 8. Change it to positive and proceed to addition. Again, when you're subtracting two integers, just change the sign of the subtrahend and proceed to addition. In our given example, the subtrahend is negative 8, changed to positive 8, and the operation subtraction becomes addition. So that's why we have P of negative 2 equals negative 2 plus 8. Bring down positive 9. Simplifying, we have P of negative 2 equals negative 2, 8 plus 9, 17. Again, in simplifying, unlike signs, just subtract the two absolute value, 17 and 2. The answer is 15. Why positive? Because the sign of the larger value is positive. 17 is larger than 2, and the sign of 17 is positive. Take the sign of the larger absolute value. That is why the answer is positive 15. We can also apply the concept of remainder theorem in finding for the unknown variable. Example number 5. Find the value of k so that the remainder is 3 or 5. Let's take letter A equals to 3. The given is 2x raised to 4 minus kx plus 4 divided by x plus 1. Solution for A equals to 3 or the remainder is equal to 3. Let the given polynomials equals to 3. So 2x raised to 4 minus kx plus 4 is equal to 3. Then our divisor is x plus 1, equate it to 0. Using addition property of equality, the value of x is equals to negative 1. Or simply, since the constant term is positive 1, change it to negative 1. Replace all x by negative 1 since the value of x is negative 1. So we have 2 times the quantity of negative 1 raised to 4 minus k times the quantity of negative 1, bring down positive 4 equals 3. Simplifying, we have 2 times the quantity of positive 1. Why positive 1? Take note that when you multiply a negative number 2 times, the answer is positive 1. 2 times, the number to be multiplied is a negative number, but the exponent here is positive. When we take a negative base and raise it to an even power, note that the product, the two negative integers, is always positive. So, negative 1 times negative 1 is positive 1. Negative 1 times negative 1 is positive 1. Positive 1 times positive 1 is positive 1. So, the pattern here is when you multiply a negative times a negative number, it is always positive. In simplifying an exponential form like this, the base is negative 1. Even the base is negative, but
po sila.
the exponent
Hello po.
is even
Good
number.
morning. Sila
The
po ay
resulting value
kumakain
is a
ng
positive
isang
number.
balot
That is
na
why negative 1 raised to 4
lagare.
is positive 1.
Ang aking tatlong
Then negative k times negative 1
mga
is positive k. Bring down positive 4 equals positive 3. Simplifying, 2 times 1 is 2. Bring down k. Bring down positive 4 equals 3. Then, copy k. 2 plus 4 is 6 equals 3. Using addition property of equality, k is equal to 3 minus 6. K equals negative 3. Why negative 3? When you subtracting unlike sign, just change the sign of the subtrahend, then proceed to addition. Here, our subtrahend is positive 6. Change this to negative 6 and proceed to addition. That is why we have 3 plus negative 6. 3 plus negative 6 is negative 3. Why negative? Because the sign of 6 is negative. 6 is larger than 3. Take the sign of the larger value. Negative 3 is the value of k. Find the value of k so that the remainder is, for letter B, 5. Again, let us equate the given dividend by the remainder 5. 2x raised to 4 minus kx plus 4 equals 5. Our divisor x plus 1 is equal to 0. Then solve for x using addition property of equality, we have negative 1. Substitute the value of x to the given expression, so we have 2 times the quantity of negative 1 raised to 4 minus k times the quantity of negative 1. Bring down positive 4 and positive 5. Simplifying, we have 2 times the quantity of 1 minus negative k times negative 1 is positive 1k. Bring down positive 4 and 5. 2 times 1 is 2. Bring down 1 times k is k. So, plus 4 equals to 5. Bring down k. 2 plus 4 is 6 equals 5. K is equal to 5. Using addition property of equality, k is equal to 5 minus 6. 5 minus 6 is negative 1. This is the value of k. Example number 6. Find the value of k so that the remainder is negative 26. Again, the given dividend should be equal to the remainder, negative 26. Our divisor here is x minus 2, equates to 0 to solve for x. Using addition property of equality, the value of x is 2. Or another trick, in solving for x, take a look at the divisor. The constant term here is negative 2. Just simply change the sign of the constant term. So that's why the value of x is positive 2. Replace all x by positive 2, so we have k times the quantity of 2 raised to 4 plus 3 times the quantity of 2 raised to 2 minus 5 times the quantity of 2 plus 4 equals negative 26. Simplifying, 2 raised to 4 is equal to 16. Multiplying 2 by itself 4 times, 2 times 2 times 2 times 2 is 16. So we have k times 16 plus 3 times 4 because 2 times 2 is 4. Negative 5 times 2 is negative 10. Bring down positive 4 and negative 26. K times 16 is 16k. 3 times 4 is 12. Bring down negative 10, positive 4, and negative 26. 16k is equal to plus positive 6. Why positive 6? 12 plus 4 is 16. Minus 10 is positive 6. Bring down negative 26. Bring down 16k and negative 26. Then again, using addition property of equality, negative 26 minus 6. 16k is negative 32. When you adding same sign, just add the absolute value and copy the common sign. To solve for k, just divide all the terms both sides by 16. So cancel the common number in the numerator and the denominator so that the value of k is negative 2.
What is the factor theorem? Let p of x be a polynomial. The factor theorem states that if p of c is equal to 0, then x minus c is a factor of p of x. Let's have some proof for letter A statement. Let's say 5 times 4 is 20. And also we can say that 20 divided by 4 is 5. And of course, the remainder is 0. Using the division algorithm, dividend is equal to the divisor times the quotient plus the remainder. From our given example, 20 is the dividend, the divisor is 4, the quotient is 5, and the remainder is 0. If we're going to let p of x as our dividend, x minus c as the divisor, p of x as the quotient, and p of c as the remainder. Replacing p of c as 0. Why 0? Because according to the given statement, p of c is 0. Therefore, p of x is equal to x minus c times q of x. Letter B. If x minus c is a factor of p of x, then p of c is 0. So, proof in B. P of x is equal to x minus c times q of x. Replace x by c, so we have p of c is equal to c minus c times q of c. C minus c is 0. 0 times q of c is 0. Therefore, we prove that the value of p of c is 0 if x minus c is a factor of the polynomial. Example, show that x minus 5 is a factor of x squared plus 4x minus 45. Take note that when we say factor, the remainder should be equal to 0. Okay, remember, if the given binomial is a factor of the given polynomial, the resulting remainder should always be 0. So, p of x is equal to x squared plus 4x minus 45. You're going to show that x minus 5 is really a factor of the given polynomial if we're going to look for a value of the remainder, which is 0, using the remainder theorem. So, in order to do that, Our given factor is x minus 5. Change it, it becomes positive 5. Replace all x by 5, so we have p of 5 equals 5 squared plus 4 times 5 minus 45. Simplifying, we have 5 squared is 25 because 5 times 5 is 25. 4 times 5 is 20. Bring down negative 45. P of 5 is 45. 25 plus 40 is 45. Bring down negative 45. 45 minus 45 is 0. Therefore, we can prove that x minus 5 is a factor of the given polynomial because the remainder is 0. Another proof is using synthetic division. Using synthetic division, we just simply copy the dividend, arrange in standard form, and copy the numerical coefficient. So we have 1, 4, negative 45. Our multiplier is 5. Then create a long line and an arrow, bring down the first term, and locate it on the third row. So that is 1. 1 times 5 is 5. You're going to add the first row and the second row. So 4 plus 5 equals 9. The number on the third row, or the numbers after the long line, is to be multiplied to the multiplier 5. So 9 times 5 is 45. Then adding negative 45 and 45, the answer is 0. Okay, take note that when you add opposite signs, just subtract your absolute value. So 45 minus 45 is 0. Hence, the remainder is 0. So we already show that x minus 5 is really a factor of the given polynomial. Another example. Find the value of k for which the given binomial is a factor of the polynomial. Our binomial here is x minus 7. X minus 7 is our divisor. But since from the given, it is not only the divisor but also the factor of the given polynomial. Solve for x for the given divisor, x minus 7. In order to do that, just simply look at the constant term. The constant term is negative 7. Change the sign, it becomes positive 7. Now, using remainder theorem, replace all x by 7. So we have here, then simplifying, since p of 7 is 0, again, using the factor theorem, when we say factor, the remainder is always 0, or the value of the polynomial when x is 7 is 0. 7 squared is 49. 7 times k is 7k. Bring down negative 21. Using addition property of equality, or we use the word transpose, we transpose 7k on the left part of the equal sign, it becomes negative 7k. What is left is 49 and negative 21. 49 minus 21 is positive 28. In order to solve for k, we're going to divide both sides by a number beside letter k, and that is negative 7. Cancel out negative 7. So we have k equals positive times negative is negative. 28 divided by 7 is 4. So the answer is negative 4. Another example. Find the value of k for which the given binomial is a factor of the polynomial. Again, the factor here is x plus 3. to find the value of k, we let p of x equal to 0. And the value of x is negative 3. Again, change the sign of the constant term. Replace all x by negative 3. We have this given expression. Again, the factor that makes the remainder is equal to 0. So that's why p of negative 3 is 0 because x plus 3 is a factor. Then performing the indicated operation, negative 3 cubed is negative 27. Why negative? Because if we raise a negative base to an odd exponent, the resulting number is always negative. So the answer is negative 27. Why 27? You're going to multiply 3 by itself 3 times. 3 times 3 is 9 times 3, 27. Again, why negative? Because the base is negative and the exponent is odd. Then, take a look at our second expression. We have negative 3 raised to 2. Notice that the base is negative, but the exponent is even number. If that's the case, the answer will be positive 9. Why positive 9? Because the exponent is even number even though the base is negative. Why? Because negative times negative is always positive. Then, 41 times negative 3 is negative 123. Bring down positive 42. 0 equals negative 27, just copy. Then k times 9 is 9k. This is the proper way of writing the letter k and the number. We should write first the number before the letter, then bring down everything. And then, using addition property of equality, so we have negative 9k. Why negative 9k? Because on the right side, that is 9k. When you move it on the left side, that will become negative 9k. Then what is left is negative 27, negative 123, and 42 on the right side. Then simplifying, we have negative 150. Why negative 150? Because when you add same signs, just add the absolute value, 27 and 123, the answer is 150. Take the common sign. So that's why the answer is negative 150. Bring down positive 42. Then, negative 9k is equal to, what is the number when you add integers with different sign? Again, you are going to subtract the two numbers even though the operation between them is addition. Why? Because they have different signs. 150 minus 42 is 108. Why negative? In adding different sign, just affix or copy the sign of the larger number. 150 is larger than 42. The sign of 150 is negative. That's why the answer is negative. Solving for k, we need to divide both terms by the number beside letter k. That is negative 9. Cancel out negative 9. What is left is letter k. Negative divided by negative is positive. 108 divided by 9 is 12. So therefore, the value of k is positive 12. Okay, thank you so much for listening.